A Ferris wheel has a radius of 80 meters and rotates in an anti-clockwise direction at a rate of 1 revolution every 72 seconds. The Ferris wheel has 16 cars that are equally spaced around the wheel as shown in the diagram. Now there's a couple of pieces of information that I'm going to get from that. One of them is actually part A of the question. We'll see that in a second. So we know that it does 2 pi radians in 72 seconds. So probably shouldn't use an equals there. So if we want to know what happens in 1 second, 2 pi over 72 is going to be equivalent to 1 second. So we're going to get pi by 36 radians per second as the rate of change of angle. And so that is d theta dt is equal to pi over 36. And you'll notice that that is part 1 of the question. Now, what else did it say? There were 16 cars equally spaced around the wheel as shown in the diagram. So 2 pi radians is all the way around. Divide by 16 is pi by 8. So that's telling us that these cars are pi by 8 radians apart. So, coordinate system is set up so that the center of the Ferris wheel is at the origin. We can see that. And ground levels y equals -80. We can see all this on the diagram. Consider a passenger car at position P. And we can see that in the diagram just here. Let t be the number of seconds the ride has been in progress from position A, which is down here at the bottom. Theta is the angle in radians the car has rotated from position A. And y is the height of the car above the center of the Ferris wheel. So in other words, just that bit. So this one is y. So we've already done that bit. In fact, I would have done that bit as soon as I saw that information at the beginning there, because we're never going to work in revolutions. We're always going to work in radians. Given that y theta is 80 sine theta plus alpha, explain why alpha is negative pi by 2. Well, we can see that from the diagram. So if we think about the diagram there and the car at position P, then we know that this is theta. We know that this angle is pi by 2. So if we just call this for a second phi, we know that y is going to be, we know that this is 80, the hypotenuse, 80 times sine phi, and from my diagram I can see that phi is equal to theta take away pi by 2, so we've got 80 sine theta minus pi by 2. Okay, what's the next part of the question say? Determine how quickly a passenger is moving upwards when they're 100 meters above the ground. Okay, so if they're 100 meters above the ground, that gives us that the y is 20. And so we can work out this angle because we know that this is 80. And we're wanting dy dt, but we know that y is 80 sine theta minus pi by 2. And we know that d theta dt is pi by 36. So using the chain rule, we can see that dy dt is going to be dy d theta times d theta dt. So dy d theta is going to be 80 cos theta minus pi by 2, and we've got multiplied by pi by 36. Well, in this case, let's call the angle, I called it phi above. So phi is going to be this is the opposite, this is the hypotenuse, the inverse sine of 20 over 80. And so theta is going to be this plus pi by 4. So just make sure I'm in radian mode first. And then I want the inverse sine of a quarter and we'll add pi by 2. So 1.823. So dy dt would be 80 cos 1.823 take away pi by 2. I wish I hadn't just added the pi by 2. I could have just gone straight to the previous, and we'll just calculate that. So the first thing I'm going to do is remove the pi by 2 again. Okay, so I want 80 times cosine of that last answer, and then we'll multiply that by pi upon 36. It gives me 6.76 meters per second. Show that the function satisfies the condition for simple harmonic motion. Well, we know that y is equal to this, but since we know that d theta dt is pi on 36, we could write that as pi t on 36, because we know every second it does pi by 36. Take away pi by 2. So dy and dt is going to be 80, we're differentiating, so this comes out and multiplies by pi on 36 cos pi t on 36, take away pi by 2, and then d2y dt squared would be 80 times pi squared. Let's write that as pi on 36 squared sine pi t on 36, take away pi by 2, and when we differentiate, because it's negative sign, so there'll be a negative in front there. And so we can recognize that because the 80 sine pi t on 36 take away pi by 2 is just the same as the original y. We can see that that's negative pi on 36 squared y, and that shows us it's SHM. A different passenger happens to be in a car that's 2 cars ahead of a particular car. At what speed correct to the nearest 0.01 meters per second is the trailing passenger moving upward when the other passenger is moving downward at exactly the same speed? If we think about it, that can only happen at one position on the wheel. If this is the vertical here, it can only happen when one of the cars is there Now the other one is 2 ahead, so that's there, so there's a car in between. And as we discussed earlier on, the angle between cars is pi by 8. So that's pi by 8. And that tells us that the theta is 7 pi by 8. So we can go back and grab this expression here, which is the dy dt. So we're going to have 80 cos 7 pi by 8 take away pi by 2 times pi on 36. Let's just go and just check that that is correct. Yeah, that's okay. So let's use the scientific. It's easier when we do virtually anything that we don't need the other one for. So let's clear that. So 80 times cosine. So this would end up being 3 pi by 8. And we'll multiply that by pi over 36. And that gives me 2.67 correct to the accuracy asked for, and that would be meters per second.